In the winter of 1944, Germany had produced approximately 6,000 Panther tanks. Beautiful machines. Technological masterpieces with sloped armor, powerful guns and engineering precision that made Allied tank designers weep with envy. That same year, the United States built over 11,000 Sherman tanks. Ugly boxes on tracks, thin armor, mediocre guns, machines that German tank crews laughed at through their periscopes. Yet by December 1944, Germany was losing the war. Not because their tanks were worse, because somehow impossibly those ugly American boxes kept appearing. Destroy 3-5 more arrive. Knock out 5-10 more roll over the horizon. A German engineer named Hans Meyer was about to discover why. What he found inside a wrecked Sherman would terrify him more than any Allied bomber raid. Because it was not a secret weapon. It was not miracle armor. It was something Germany could never copy, and it would cost them everything. The situation in late 1944 was catastrophic for German armored forces, though few dared admit it openly. On paper, German tanks remained superior. The Panther could penetrate a Sherman from distances where American shells simply bounced off its sloped frontal armor. The Tiger was a legendary beast that Allied tank crews feared with almost superstitious dread. 5 Shermans for 1. Tiger, the saying went. Sometimes the ratio was even worse. In a tank duel, Germany won almost every time. But tank duels were becoming irrelevant. The problem was not combat performance. The problem was numbers. Every month, Allied intelligence reports showed American tank production climbing. Factories in Detroit and Ohio and Pennsylvania churned out Shermans around the clock. Workers who had built automobiles the year before now assembled war machines with the same efficiency they once applied to Chevrolets and Fords. Meanwhile, German production struggled. The Panther required over 150,000 man-hours to build. The Tiger needed even more. Specialized workers' precision tools, complex assembly processes that could not be rushed without sacrificing quality. And quality was sacred. German engineering culture demanded nothing less than perfection. Each tank was a masterpiece. Hand-fitted, carefully tuned, assembled by craftsmen who took pride in every weld and every gear. The result was predictable. When a Panther broke down on a Russian road or a French lane, repair could take days, sometimes weeks. Spare parts were chronically short because each component was unique, machined to tolerances that made interchangeability difficult. Crew members joked darkly that the best way to fix a Panther was to find a dead one and scavenge parts. German high command noticed the discrepancy but misunderstood its significance. They believed the problem was temporary. Surely American quantity could not compensate forever for German quality. Surely those thin-skinned Shermans would eventually prove inadequate against superior German firepower. They were wrong. Every intelligence report from the front told the same story. Shermans destroyed in the morning were replaced by afternoon. Damaged Shermans were dragged to field depots and returned to action within days, sometimes hours. American tank crews treated their vehicles almost casually, knowing that if one was lost, another waited. German crews treated their Panthers and Tigers like precious jewels, because they were precious, irreplaceable, and replacement was becoming the only metric that mattered. But everything was about to change because of a man nobody in German high command had ever heard of. His name was Hans Meyer, and he was not a soldier. He was not a general or a strategist or a weapons designer. He was simply an engineer, 43 years old, with graying hair and calloused hands that had spent 2 decades solving factory problems. Before the war, Hans had worked in civilian manufacturing, building machine tools, optimizing production lines, eliminating waste wherever he found it. He had one obsession that colleagues considered almost religious. He hated inefficiency. Not just wasted material, but wasted time, wasted movement, wasted complexity. Every unnecessary step in a process offended him personally. Every elegant solution that was too complicated to be practical made him physically uncomfortable. When war came, Hans was drafted into military production assessment. His job was to analyze captured enemy equipment and identify anything useful for German manufacturing. It was tedious work. Most captured equipment was damaged beyond study or revealed nothing the Reich did not already know. But Hans approached each assignment with the same methodical intensity he brought to everything. Then, in November 1944, a burned-out Sherman tank arrived at his facility. Dragged from a battlefield in France, its paint-blistered one-track blown-off turret jammed at an ugly angle. Standard procedure was to catalog armor thickness, gun specifications, engine performance. Basic technical data. But Hans felt something different when he first walked around the wrecked American tank. It looked wrong, too simple, too crude. The welds were rough. The castings lacked the precision he saw in German armor. The design seemed almost careless, as if whoever built it had been in too much of a hurry to do it properly. And yet this ugly machine and thousands like it were winning the war. Hans gathered his team the next morning. Young engineers, draftsmen, a few soldiers on temporary assignment. Today he announced quietly, "We perform an autopsy. We open this American machine and discover what makes it so difficult to kill." The idea seemed almost ridiculous at first. Every German engineer knew the Sherman was inferior. Thinner armor, weaker gun. A silhouette so tall it might as well have a target painted on the turret. When Hans announced his intention to conduct a detailed teardown, a young draftsman named Kurt laughed openly. "Why bother?" he asked. "Everyone knows what we will find. Soft steel, poor welding an aircraft engine shoved into a tank chassis because Americans cannot build proper power plants." Hans looked at him mildly. "Yes," he replied. "Everyone knows." He picked up a piece of chalk and drew a line along the Sherman's hull. "But I prefer not to believe everyone. I prefer to look." What Hans proposed was not a standard technical assessment. He wanted to completely disassemble the Sherman, cataloging not just what it contained, but how it was designed to be manufactured and maintained. He wanted to understand the philosophy behind the machine, not just its specifications. His superiors approved reluctantly. Resources were scarce, manpower scarcer. But Hans had a reputation for producing useful reports, and the mystery of American production numbers was becoming impossible to ignore. So the torches ignited. Sparks showered the workshop floor as Hans and his team began cutting into the Sherman's skin. The smell of burned paint and hot steel filled the air, and piece by piece, the ugly American tank revealed its secrets. None of them were what anyone expected. The first section of armor came away with a groan of stressed metal. Kurt leaned in immediately, expecting confirmation of everything he believed about American manufacturing inadequacy. The edge of the plate was rough, nothing like the precision-machined armor he worked with on German tanks. "Cast," he announced dismissively. "Not even rolled plate." Hans nodded thoughtfully. "Yes," he said. "Large castings, not carefully machined sections welded together." He traced the edge with his finger. "Fewer welds, less precision work, faster production." Kurt frowned. "Is that supposed to be good?" Hans smiled faintly. "That depends," he replied. "Do you want perfection, or do you want 10,000 tanks?" They removed more sections methodically. The interior revealed itself: crew positions, ammunition, storage radio equipment, engine compartment. Hans climbed inside, squeezing through the cramped spaces that no tank ever made comfortable. And he noticed something immediately. He could reach things. Controls were positioned where hands naturally wanted to go. Hatches opened cleanly without requiring specific sequences. The driver's position had an almost civilian logic to it, like the cab of a truck rather than a precision military instrument. "This feels like a truck," Hans murmured. "A truck you can fight in." Kurt squeezed in behind him, bumping his head on a bracket. "It is ugly," he complained. "Yes," Hans agreed. "It is ugly in exactly the right way." He pointed to the gearbox. Simple design, robust construction, not finely tuned to extract maximum performance from a narrow operating range. He tapped a control cable. Routed to avoid sharp bends. Easy to adjust, easy to replace, Easy for a mechanic who learned his trade last month to understand. He turned slowly, studying every surface. "Look at the access panels," he said quietly. "The way components are mounted. This machine was designed to be repaired by tired men with cold hands in the dark, not by craftsmen in workshops." Kurt examined a weld seam. "The finish work is terrible," he observed. Hans smiled. "Finish work does not stop shells," he replied. "Finish work does not tow your broken tank off a frozen road." He ran his hand along a casting. They saved precision for where it matters. They spent engineering effort on what actually wins wars, not on pride. The engine compartment confirmed everything Hans was beginning to suspect. When the rear plate came off, Kurt stared in genuine surprise at the power plant revealed. It was a radial aircraft engine, the R-975. Massive, loud, fuel-hungry, and designed for an entirely different purpose than pushing a tank across a battlefield. "They really do use aircraft engines," Kurt said. "Do they have so many, they simply put them in tanks?" Hans examined the mounting system carefully, ignoring the engine itself. "Perhaps," he replied. "But note this." He pointed to the way the engine sat on its cradle. Standardized interfaces, bolted in where it can be removed as a complete unit. He gestured to access panels on the floor. A crew with a crane could lift this entire mass out in hours, replace it with another engine, and return the tank to combat in a single day. Kurt frowned. "Can we not do the same?" Hans thought of the Panther's engine bay, the tightly packed components, the parts that had to be removed in specific sequences before anything else could be reached. "In theory," he said slowly, "if we designed for field maintenance instead of engineering elegance." The real revelation came when Hans found a small compartment containing a packet of papers sealed in a plastic bag. An American maintenance manual. He called for Friedrich, a colleague who spoke English, and together they began translating. The manual was unlike anything Hans had ever seen in German military documentation. It spoke directly to tank crews as if they were intelligent partners rather than interchangeable components. Troubleshooting flowcharts, step-by-step instructions with illustrations. "When you hear this noise, it probably means this. Check here first. If that does not solve the problem, try this next." Kurt snorted when Friedrich read passages aloud. "Do they think their crews are children?" Hans did not answer immediately. He studied a diagram showing how to adjust track tension with minimal tools. "No," he said finally. "They think their crews are valuable, too valuable to waste on guessing why their machine will not start. So they explained everything clearly, assuming the soldier reading might be a farmer who learned to drive a tractor last year." The manual represented something Hans could barely articulate. It was not just documentation, it was respect. Respect for the limitations of real human beings under the stress of real combat conditions. The first practical application of Hans's discoveries came faster than anyone expected. A Panzer Division commander, desperate to keep his remaining vehicles operational, requested any insights that might help his mechanics. Hans sent a simplified report with specific recommendations borrowed from American practice. Standardize fasteners where possible. Position access panels based on what needs frequent maintenance. Stop designing for ideal conditions that never exist in actual combat. The results were modest but measurable. Repair times improved slightly. Vehicles returned to action faster. But the deeper implications were impossible to implement within existing German industrial culture. The entire system was built around precision, around perfection, around the belief that superior quality would always triumph over inferior quantity. That winter, as Allied forces pressed from West and East, German tank commanders fought with increasing desperation. Panthers and Tigers extracted terrible tolls from attacking Shermans. Kill ratios remained favorable. One German tank might destroy 3, 4, 5 American vehicles before being overwhelmed. But the mathematics were merciless. Every German loss was nearly irreplaceable. Every American loss was already replaced. And Hans Meyer sat in his workshop at night surrounded by Sherman components, understanding with terrible clarity exactly why Germany was going to lose. But Hans had only begun to understand the true dimensions of American industrial philosophy. The Sherman was merely one example of a systematic approach to warfare that Germany had never contemplated. As 1944 turned to 1945, Hans would discover that the secrets inside the Sherman were connected to something far larger, a machine that spanned oceans, employed millions, and operated with a logic that made individual German genius almost irrelevant. In Part 2, we will see how American production methods evolved from automobile factories into the most powerful war-making apparatus in human history. We will meet the workers who built tanks like they once built cars, and the managers who understood that consistency mattered more than brilliance. And we will watch as German commanders slowly realized that every tactical victory, every destroyed Sherman, every successful ambush was meaningless against an enemy who could replace losses faster than Germany could count them. The real war was not being fought on battlefields. It was being fought in factories, and Germany had already lost. In Part 1, we watched Hans Meyer cut open a captured Sherman tank, expecting to find secret armor or miracle technology. Instead, he found something far more terrifying: crude welds that worked, simple designs that any mechanic could repair, maintenance manuals that treated soldiers like intelligent partners. He discovered that American tanks were not built to win duels. They were built to be everywhere. But understanding the problem was one thing. Convincing German high command was another. Hans had prepared a detailed report documenting everything his team discovered: standardized fasteners, modular engine mounts, access panels positioned for field repair rather than factory convenience. He believed the evidence spoke for itself. He was about to learn that evidence means nothing when it threatens everything powerful men believe. In December 1944, the German military establishment was not interested in hearing that their enemy had solved problems Germany could not even acknowledge existed. And Hans Meyer was about to walk into a room full of men who had built their careers on the superiority of German engineering. The meeting took place in a gray concrete building that had somehow survived Allied bombing raids. Around a long wooden table sat 6 officers, their uniforms decorated with tank badges and staff insignia. At the head sat General Major Werner Hoffmann, a man who had commanded panzer divisions since the invasion of Poland. His reputation was built on German armored superiority. His entire understanding of warfare depended on the premise that quality would always defeat quantity. Hans stood at the front of the room with his diagrams and charts. He had rehearsed his presentation carefully, focusing on practical recommendations rather than criticism. But within minutes, everything went wrong. The Sherman armor, Hans explained, is adequate but not remarkable. The gun is inferior to ours in penetration. The engine is loud and consumes excessive fuel. Hoffmann nodded impatiently. "We know all this," he interrupted. "Your report wastes our time stating the obvious." Hans took a breath. "The obvious, Herr General, is not the point." He moved to his next chart, showing the Sherman's interior layout. "The point is how this tank was designed. Not for maximum performance, but for maximum replaceability." He explained the modular engine mounting, the standardized components, the maintenance philosophy that assumed repairs would happen in muddy fields rather than proper workshops. Hoffmann's face darkened with each word. "You are telling me," he said slowly, "that we should learn from inferior American engineering?" Hans hesitated. "I am telling you, Herr General, that their engineering philosophy produces more operational tanks per day than ours. And in this war, operational tanks matter more than technical specifications." The room went silent. A staff colonel cleared his throat. "Are you suggesting we abandon German precision, that we build worse tanks deliberately?" Hans shook his head. "I am suggesting we build tanks for the war we are actually fighting, not for the war we wish we were fighting." Hoffmann stood abruptly. His chair scraped against the floor. "This meeting is concluded," he announced. "Engineer Meyer, your report will be filed." He paused at the door. "And I suggest you remember that German engineering won victories across Europe while American factories built refrigerators. Do not presume to lecture men who have actually fought. The door closed behind him. Hans gathered his charts in silence. The other officers filed out without looking at him. Only one man remained, a younger colonel, who had said nothing during the entire meeting. His name was Otto Brandt, and he commanded a tank recovery and repair battalion. He had spent 3 years watching German masterpieces break down in conditions they were never designed for. "I read your full report," Brandt said quietly. "The part about the maintenance manual." Hans looked up. "Yes." Brandt smiled grimly. "I have lost more tanks to mechanical failure than to enemy fire." He stepped closer. "I think you found something important, and I think we need to prove it in a way even Hoffman cannot ignore." Otto Brandt was not a famous officer. He commanded no combat divisions, led no dramatic charges. His job was unglamorous but essential. When Panthers broke down, or Tigers threw tracks, his teams dragged them to repair depots and somehow made them run again. He had seen more German tank interiors than any general, and he knew exactly what Hans was describing. The question Brandt said that evening over weak coffee in Hans's office is not whether you are right. I know you are right. I have watched mechanics spend 8 hours accessing components that should take 20 minutes to reach. Hans nodded wearily. Then why does High Command refuse to listen? Because admitting the problem means admitting that everything they believe about German superiority is wrong. Brandt set down his cup. They would rather lose the war than their pride, but we might convince them with a demonstration they cannot dismiss. His plan was simple but risky. Brandt's battalion had recently recovered both a damaged Panther and a damaged Sherman from the same engagement. Both needed similar repairs, transmission work, and track replacement. Brandt proposed a timed competition. 2 repair crews, equal skill levels, identical repair tasks. One working on the Panther, using standard German procedures. One working on the Sherman, following American maintenance methods. "Let the clocks decide who is right," Brandt said. Hans considered the risks. "If we fail," he said slowly, "Hoffman will have both our careers." Brandt shrugged. "If we do nothing, Germany loses the war. At least this way we tried." They scheduled the demonstration for January 15, 1945. They had 3 weeks to prepare. 3 weeks to gather tools, train crews, and arrange for enough senior officers to witness the results. 3 weeks before everything Hans believed would be tested in front of men who wanted him to fail. The night before the demonstration, Hans could not sleep. He walked through the repair bay where both tanks waited under canvas covers. The Panther gleamed even in dim light, its sloped armor catching shadows like a sculpture. The Sherman squatted beside it, blocky and graceless, its rough welds visible even in darkness. Tomorrow, Hans whispered to himself, we find out if ugly can beat beautiful. January 15th. Dawned gray and cold. Light snow dusted the repair facility grounds. By 9 in the morning, a small crowd had gathered. General Major Hoffman stood at the front, his face carefully neutral. Behind him clustered staff officers, factory representatives, and several tank commanders pulled from nearby units. Otto Brandt had arranged seating and refreshments, treating the event like a formal exhibition rather than a desperate gamble. Hans appreciated the theater. If they were going to be humiliated, at least they would be humiliated professionally. The rules were announced clearly. Both tanks required identical repairs. Transmission removal and reinstallation. Track replacement on the left side. The work would be performed by crews of 4 mechanics, each selected for equal experience levels. Tools and parts were pre-positioned. Time would be measured from first wrench turn to final inspection. Any questions Brandt asked. Hoffman shook his head. Proceed. The starting whistle blew at exactly 1000 hours. Hans watched from the sideline, his hands clasped behind his back to hide their trembling. The Panther crew moved with practiced efficiency, their movements choreographed by years of training. They opened access panels in prescribed sequences, removed components in proper order, documented each step according to regulation. It was beautiful to watch, precise, professional, exactly as German engineering demanded. The Sherman crew worked differently. Their movements seemed almost casual by comparison, less elegant. But Hans noticed something immediately. They were faster. Not rushing, not cutting corners, simply not performing steps that served no purpose. The Sherman's transmission mount used standardized bolts that matched 3 other major components. The Panther's transmission required 17 different fastener types, each demanding specific tools. By the 30-minute mark, the difference was visible. The Sherman crew had already extracted their transmission unit completely. The Panther crew was still removing secondary components that blocked access to their primary target. Hoffman frowned. He leaned toward a staff officer and whispered something. The staff officer shook his head. 1 hour passed. The Sherman's transmission sat on a repair cradle while the crew performed their service work. The Panther crew had finally reached their transmission, but was struggling with a seized bolt that required a specialized tool nobody could immediately locate. Hans watched Hoffman's expression shift from skepticism to something more complicated. 2 hours. The Sherman crew was already reinstalling their service transmission. The Panther crew had their transmission out, but discovered that a gasket had been damaged during removal, a common problem caused by the tight tolerances that made German engineering so admirable and so fragile. They sent a runner for replacement parts. The Sherman crew began track work. 3 hours. Track replacement on the Sherman proceeded smoothly. The American design used a simpler tensioning system that could be adjusted with basic tools. The Panther's track system was more sophisticated but required careful calibration that the field manual described across 14 separate pages of instructions. 3 hours and 47 minutes after the whistle, the Sherman crew's leader raised his hand. "Repairs complete," he announced. "Ready for inspection." The Panther crew was still fighting with track tension. Their transmission was reinstalled, but final adjustments remained incomplete. Hans stepped forward with a checklist. He inspected the Sherman's work, methodically checking each repair point, testing each connection. He found no deficiencies. The work was rough by German standards. Welds were functional rather than pretty. Bolts were tight, but not torqued to laboratory specifications. Everything worked. Sherman repairs complete in 3 hours. 47 minutes, Hans announced to the crowd. All systems functional. The Panther crew finished at 5 hours and 12 minutes. Their work was immaculate. Every specification met precisely. Every regulation followed exactly. And they had taken 37% longer to achieve the same result. The mathematics were devastating. In the time required to repair one Panther, American methods could repair nearly 1.5 Shermans. Across an entire army, across thousands of vehicles, that difference meant hundreds of additional tanks in combat at any given moment. Hoffman said nothing for a long moment. His face had gone pale. Finally, he turned to Hans. "Your recommendations," he said quietly. "Prepare a detailed implementation plan." He paused. "You have 2 weeks." The next month became a blur of activity. Hans and Brandt worked around the clock, preparing training materials, identifying components that could be standardized, redesigning maintenance procedures for field conditions rather than factory ideals. Resistance came from everywhere. Factory managers protested that changes would disrupt production. Design engineers argued that simplification meant degradation. Training officers complained that new procedures would confuse crews already familiar with existing methods. Hans learned to navigate bureaucratic warfare as carefully as any battlefield. He compromised where he could, insisted where he could not, and slowly built a coalition of pragmatists who cared more about winning than about pride. The first field implementations began in February 1945. Selected repair battalions received new procedures, simplified tool sets, and maintenance manuals written in the direct style Hans had admired in the American documents. Results varied. Some units embraced the changes, eagerly grateful for anything that made their impossible jobs slightly less impossible. Others resisted viewing the new methods as insults to their professionalism. But the numbers told a consistent story. Units using the new procedures returned damaged vehicles to service an average of 40% faster than units using traditional methods. In a war of attrition, 40% was the difference between survival and annihilation. Reports from the front confirmed what Hans had predicted. German tank commanders noticed that replacement vehicles arrived faster. Mechanics reported less frustration with inaccessible components. A Panther commander wrote that for the first time he felt his tank might actually be repaired before the war ended. But success brought new problems. Word of Hans's reforms spread through official channels and unofficial rumors. Some officers praised the innovations. Others condemned them as defeatist, as admissions of German inferiority. And somewhere in the chaos of a collapsing Reich, someone decided that Hans Meyer's work was worth investigating more closely. By March 1945, Hans had trained over 200 mechanics in his new procedures. He had revised maintenance documentation for 3 major vehicle types. He had even begun consulting with factory engineers about incorporating field lessons into production design. He believed, perhaps naively, that he was helping Germany survive. But the war was already lost, and some men were looking for scapegoats rather than solutions. A summons arrived on March 12th. Hans was ordered to report to a military intelligence office in Berlin for questioning about his contacts with captured enemy materials. The accusation was never stated directly, but the implication was clear. Someone believed that Hans's enthusiasm for American methods indicated something darker than professional admiration. Otto Brandt heard about the summons within hours. He arrived at Hans's office with a grim expression. "You need to disappear," he said, "at least until this insanity passes." Hans shook his head. "If I run, they will assume I am guilty of whatever they imagine." Brandt grabbed his arm. "If you stay, they will find you guilty regardless of truth. These are not rational times." They argued for an hour. In the end, Hans agreed to transfer to a frontline repair unit where military police were less likely to look. He packed his research notes, his precious American maintenance manual, and what little personal property he still possessed. The next morning, he boarded a truck, heading east toward the front lines, toward the chaos where Germany's beautiful tanks were dying faster than anyone could repair them. He did not know that his work had attracted attention beyond Germany's borders. American intelligence had intercepted reports about a German engineer studying Sherman production methods. They were curious what the enemy had learned, and they were coming to find out. In Part 3, we will follow Hans to the crumbling Eastern Front, where his knowledge becomes both weapon and liability. We will see German commanders making impossible choices as their masterpiece tanks fail one by one. And we will discover what happens when an engineer who understood the Sherman's secrets finally meets the men who built it. The autopsy was complete, but the patient was still dying, and some secrets are worth more than the men who discover them. In Part 1, Hans Meyer cut open an American Sherman tank and discovered that its secret was not armor or firepower, but a philosophy of building machines for real human beings in real combat conditions. In Part 2, he fought German bureaucracy, proved his theories in a dramatic repair competition, and began implementing reforms that returned damaged vehicles to combat 40% faster. But his success attracted dangerous attention. Military intelligence summoned him for questioning about his enthusiasm for American methods. To survive, Hans fled to the Eastern Front, carrying his research notes and the American maintenance manual that had changed everything he understood about industrial warfare. He thought he was escaping danger. He was walking directly into it, because American intelligence had intercepted German communications about an engineer studying Sherman production methods. They wanted to know what he had learned. And as April 1945 approached, the Reich was collapsing so fast that finding one engineer in the chaos seemed almost impossible. Almost. The report landed on Captain William Torres's desk in early March 1945. Torres worked for a specialized unit tasked with capturing German technical personnel and documents before the Soviets could reach them. Most targets were rocket scientists, jet engine designers, nuclear physicists. The glamorous prizes. But this report was different. German engineer conducting detailed analysis of American Sherman tank design and manufacturing philosophy. Torres read aloud. Implementing reforms to German maintenance procedures based on American methods. His assistant, Lieutenant Sarah Chen, frowned. Why do we care what they learned about Shermans? They are losing anyway. Torres set down the report. Because whatever he learned might tell us things we do not know about our own equipment. He tapped the paper. And because if this engineer is smart enough to understand what makes our tanks work, he might be smart enough to help us understand what makes their tanks fail. The hunt began immediately. Intelligence networks activated across occupied Germany. Interrogators added new questions to their standard lists. Have you heard of an engineer named Hans Meyer? Have you seen reports about American tank analysis? Within 2 weeks, Torres had assembled fragments of information. Hans had worked at a facility near Kassel. He had presented findings to senior officers who rejected them. He had recently been transferred to a frontline repair unit somewhere in the east. Finding him would require getting closer to active combat than Torres preferred. But the potential value was too significant to ignore. By late March, American forces were pushing deep into Germany. Somewhere ahead in the chaos of retreat and collapse, Hans Meyer was trying to keep broken tanks running long enough to matter. He did not know that Americans were searching for him. He did not know that his meticulous reports had been intercepted and translated. He only knew that every day brought fresh disasters, and his carefully developed procedures meant nothing when there were no spare parts, no fuel, and no time. The repair depot was a converted barn near a village whose name Hans never learned. Around it, the sounds of distant artillery rumbled like continuous thunder. His unit had 17 vehicles requiring service. They had parts for perhaps 3. The mathematics of collapse, Hans thought grimly. We can calculate exactly how we are dying. His commanding officer, an exhausted major named Dietrich, called a meeting that evening. The Soviets will be here within a week, Dietrich announced. Perhaps sooner. We have orders to repair what we can and retreat west. He looked at Hans. Your American methods. Can they help us now? Hans wanted to laugh. His methods required standardized parts. They required functional logistics. They required an industrial base that no longer existed. My methods, Hans said, carefully assumed we still had a war to fight. He gestured toward the broken Panthers outside. These machines need components that German factories stopped producing months ago. A young mechanic named Dieter spoke up. Then what do we do? Hans thought of the Sherman manual in his pack. The section about improvisation, about making repairs with whatever materials were available, about treating each tank not as a precision instrument, but as a tool that needed only to work well enough for one more mission. We adapt, Hans said. We stop trying to restore perfection. We focus on making things move and shoot. Nothing else matters now. The next 3 days became a blur of desperate improvisation. Hans taught his crews to cannibalize parts from destroyed vehicles, to substitute materials when specifications could not be met, to accept rough solutions that would have horrified German engineering culture. It was ugly work. It violated everything Hans had been trained to value. But tanks that had sat dead for weeks began moving again. Not beautifully, not properly, just well enough. On the 4th day, a courier arrived with news that changed everything. American forces had captured a German officer who mentioned Hans by name. The Americans were asking about him specifically. They knew about his Sherman research. They wanted to find him. Dietrich pulled Hans aside after reading the message. You need to decide, he said quietly. The Soviets will not care about your engineering knowledge. They will send you to a camp where you will disappear. He paused. The Americans might offer something different. Hans stared at the message. For months he had studied American methods with professional admiration. Now those same Americans were hunting him like a prize. What did they want? What would they do with him? He thought about the Sherman manual still hidden in his pack, about the philosophy of building machines for real human beings. If any nation might understand what he had learned, It would be the people who had created that philosophy in the first place. "I need to reach American lines," Hans said. "But first, we finish what we started here." The village was called Steinbach. It sat at a crossroads that both Soviet and American forces wanted to control. German commanders had decided to defend it long enough to allow retreating units to pass through. Hans's repair depot was directly in the path of the Soviet advance. April 4th, 1945. Dawn came gray and cold. Hans had worked through the night coaxing 3 more Panthers back to minimal functionality. Not combat-ready by any proper standard, but able to move, able to fire, perhaps able to survive long enough to matter. The Soviet attack began at 700 hours. Artillery first. Shells screamed overhead, exploding in the village and surrounding fields. Hans pressed himself against the barn wall, feeling the structure shake with each impact. Then silence. Worse than the explosions. Because silence meant the infantry was coming. Major Dietrich's voice crackled over a radio. "All units defensive positions." Hans grabbed a rifle he barely knew how to use and ran toward the line. The scene that greeted him was chaos organized by desperation. German soldiers crouched behind hastily built barricades. The 3 Panthers Hans had repaired sat in hull-down positions, their guns tracking east, and coming toward them across open fields Soviet T-34 tanks. Hans counted quickly. 8, 10, 12. More behind them. The lead Panther fired. A T-34 erupted in flames. The Soviet formation scattered, spreading out to make targeting harder. Return fire. A shell slammed into the barricade near Hans. Men screamed. Someone dragged a wounded soldier toward cover. The second Panther fired. Another T-34 stopped smoke pouring from its engine deck. But the Soviets kept coming. They had learned the same lesson Hans had discovered in the Sherman. Numbers mattered more than individual quality. Lose 2 tanks, 3 more replace them. Hans watched the mathematics of attrition playing out in real time. 1 Panther took a hit. Its crew bailed out as flames licked from the engine compartment. Hans thought of the repair procedures that might have saved it if there had been time. There was no time. The Soviets reached the village edge. Infantry dismounted from trucks and began fighting house to house. The remaining 2 Panthers pivoted to provide close support, their machine guns cutting through Soviet soldiers attempting to cross open ground. Hans found himself firing his rifle at shapes moving between buildings. He had no idea if he hit anything. He only knew that stopping meant dying. Then he heard it. A new sound. Different engines. Coming from the west. American Shermans. 3 of them advancing cautiously along the main road from the direction Hans had dreamed of reaching. For a moment, Hans thought rescue had arrived impossibly early. Then the lead Sherman opened fire. On the German positions. The shell missed Hans by meters. He threw himself flat as debris showered around him. The Americans were not rescuing anyone. They were attacking. Caught between Soviet forces from the east and American forces from the west, the German defenders began to collapse. Soldiers ran in every direction. Some surrendered to Soviets. Some tried to flee. Some simply died where they stood. Hans saw Major Dietrich fall, hit by something he never saw. The remaining Panther tried to engage the Shermans. It destroyed one before the other 2 found its flank. German engineering perfection versus American industrial philosophy. In this engagement, quantity won. Hans dropped his rifle. He raised his hands. He walked toward the American line, shouting the only English words he could remember. Engineer. I am engineer. Sherman. I know Sherman. A Sherman commander spotted him through his periscope. A thin German man walking through a battlefield with his hands up, shouting something about engineering. Normally, he would have been processed as a regular prisoner. But Captain Torres had briefed every unit in the sector. Watch for an engineer asking about Shermans. Valuable asset. Capture alive. 20 minutes later, Hans sat in the back of an American half-track, surrounded by soldiers, who regarded him with suspicious curiosity. His Sherman manual was still in his pack. His research notes were still intact. And ahead somewhere in the chaos of collapsing Germany, William Torres was already en route to conduct the most unusual interrogation of his career. News of Steinbach spread through American intelligence channels within hours. German engineer captured. Claims extensive knowledge of Sherman analysis. Request to speak with technical personnel. Torres reached the prisoner-holding area by nightfall. He found Hans sitting on a crate still covered in dirt and dried blood from the battle. Not his own blood. "You are Hans Meyer," Torres said in careful German. Hans nodded. "And you are looking for me?" Torres smiled slightly. "You have been busy." He sat down across from Hans. "Tell me what you found when you opened our tank." The conversation lasted 6 hours. Hans explained everything. The modular engine mounts, the standardized fasteners, the maintenance philosophy that treated soldiers as valuable partners, the manual that spoke to mechanics like intelligent adults. Torres listened without interrupting. When Hans finished, he was quiet for a long moment. "You understood us better than most Americans understand ourselves," Torres said finally. He leaned forward. "What do you want?" Herr Meyer. Hans thought about the question carefully. "I want to build things that work," he said. "I want to solve problems that matter." He looked at Torres. "I no longer care which flag flies over the factory." Torres nodded slowly. "We might be able to arrange that." The war in Europe ended 33 days later. Hans Meyer spent those weeks in comfortable custody, debriefing American technical teams about everything he had learned. His insights proved valuable in unexpected ways, not because he had discovered American secrets, but because his outside perspective revealed efficiencies that American engineers had achieved without fully understanding why they worked. His analysis of the Sherman maintenance philosophy was compiled into a report that influenced post-war military vehicle design. The principle of designing for the worst case for tired mechanics with limited tools for real human limitations, rather than ideal conditions, became standard doctrine. Hans Meyer never received public recognition. His name appeared in no histories of the war. He was a footnote in classified documents, an anonymous contributor to engineering principles that would shape military manufacturing for decades. But he had survived. And in the ruins of a war that had consumed 50 million lives, survival was no small achievement. Yet one question remained. Hans had discovered the Sherman secret. He had understood why American industry defeated German engineering. But understanding a problem and accepting its implications were different things. In his final debriefing session, Torres asked him a question that Hans would think about for the rest of his life. "If you had found these secrets earlier," Torres asked, "could Germany have won?" Hans was silent for a long time. He thought about the Panthers and Tigers that had dominated every battlefield duel. He thought about the Shermans that kept appearing, regardless of how many were destroyed. He thought about factories in Detroit running 3 shifts, while German facilities struggled to find workers and materials. "We could not have won," Hans said finally, "because the Sherman secret was never really about the tank." He looked at Torres with eyes that had seen too much. It was about building a society that could afford to lose 10,000 of anything and simply build more. He shook his head slowly. "We built masterpieces. You built a system. Against a system, masterpieces are just expensive targets." The story of Hans Meyer could have ended there. A German engineer saved by the Americans, contributing his knowledge to his former enemies, living quietly in obscurity, while history forgot his name. But history had one more chapter to write. And it would reveal something about the Sherman secret that even Hans had not fully grasped. In Part 4, we will follow Hans into post-war America, where he would see the factories that had buried his country in steel. We will discover what happened to the men who rejected his warnings and the men who believed him. And we will learn the final lesson of the Sherman tank, a lesson about what it really means to build machines for human beings instead of for glory. The autopsy was complete. The patient had died. But the surgeon who performed it was about to discover that some secrets matter more in peace than they ever did in war. In Part 1, Hans Meyer cut open an American Sherman tank, expecting to find secret armor or miracle technology. Instead, he discovered something far more terrifying: a design philosophy that treated tanks as disposable tools rather than precious masterpieces. In Part 2, he proved his theories in a dramatic repair competition, demonstrating that American methods could return damaged vehicles to combat 40% faster than German procedures. In Part 3, he fled military intelligence investigators, survived the Battle of Steinbach, and was captured by American forces, who had been specifically hunting for him. His knowledge of the Sherman's secrets made him valuable to both sides of a collapsing war. But the war ended. Germany surrendered. The guns fell silent across Europe. And Hans Meyer found himself in a strange new world, a German engineer working with the people whose industrial philosophy had destroyed his country. What happened next would reveal the final lesson of the Sherman tank, a lesson that had nothing to do with armor thickness or gun caliber, a lesson about what it really means to build things for human beings instead of for glory. Because the secret Hans discovered in 1944 would echo through decades of military and industrial history, and its implications would prove more profound than anyone, including Hans himself, had ever imagined. Captain William Torres kept his promise. In the months following Germany's surrender, Hans Meyer was not sent to a prisoner camp or shipped back to face denazification tribunals. Instead, he was quietly transferred to a technical assessment unit operating out of Munich, where his knowledge of German engineering practices proved invaluable. American teams were scouring defeated Germany for technical secrets: jet engines, rocket technology, advanced optics, weapons that might provide advantages in future conflicts. Hans helped them understand not just what German engineers had built, but why they had built it that way. The philosophy behind the engineering, the cultural assumptions that shaped every design decision. It was strange work. Hans found himself explaining German thinking to Americans, who often understood their own achievements better than the Germans who had studied them. "You built for the factory floor," Hans told one group of engineers. "We built for the drafting table. You asked what an average worker could assemble. We asked what a perfect engineer could design." The difference seemed small. It was everything. In June 1946, Hans received an unexpected invitation. A delegation of American automotive engineers was touring European facilities studying manufacturing methods. They wanted to meet the German who had written detailed reports about American tank production philosophy. Hans agreed reluctantly. He expected criticism, perhaps mockery. Instead, he found something that surprised him deeply. The American engineers were genuinely curious about his observations. They asked questions he had never considered. They pointed out efficiencies in their own systems that they had implemented without fully understanding why they worked. "Your report on our maintenance manuals," one engineer said. "We never thought about it the way you described. We just wrote them the way we write car manuals. Simple language, clear steps assume the reader is smart but busy." Hans nodded slowly. "That assumption," he said quietly, "is what won the war." The meeting lasted 3 hours. By the end, Hans had received informal job offers from 2 different American companies. He declined both. His wife and children were still in Germany, living with relatives in a bombed-out city. He could not simply abandon them for American opportunity. But the door had been opened. In 1948, Hans finally emigrated to the United States under a technical specialist visa. His family joined him 6 months later. They settled in Ohio near automotive factories that reminded Hans of the industrial philosophy he had spent years studying from the outside. He never became famous. His name appeared in no histories. He worked as a manufacturing consultant for companies that had no idea he had once dissected their war machines in a German workshop. But he was alive. His family was safe. And the lessons he had learned inside that burned out Sherman would quietly influence American industrial practices for years to come. His former allies fared differently. Otto Brandt, The repair battalion commander who had believed in Hans's ideas survived the war, but spent 2 years in Soviet captivity. He returned to Germany, broken in health, dying in 1952, without ever knowing that the reforms he had championed had attracted American attention. General Major Hoffman, who had dismissed Hans's findings as defeatist, was killed in the final days of fighting when his command post was overrun by Soviet forces. His belief in German engineering superiority died with him. The young draftsman Kurt, who had mocked the Sherman's crude welds, was captured by American forces and spent months in a prisoner camp. After the war, he became an automotive engineer in the new West Germany, where he quietly implemented many of the standardization principles Hans had first identified. He never acknowledged the irony. But the legacy Hans left behind was not measured in personal recognition or career success. The philosophy Hans discovered inside the Sherman tank did not end with World War II. It became a fundamental principle of American military manufacturing that would shape conflicts for generations. The concept was simple, but revolutionary. Design for the worst case. Assume maintenance will happen in bad conditions with limited tools. Assume operators will be trained quickly rather than extensively. Assume replacement is inevitable, so make it efficient. These principles transformed how America built military equipment. When the Korean War began in 1950, American forces fielded improved Sherman variants alongside newer designs. The maintenance philosophy remained unchanged. Tanks could be repaired in forward positions. Damaged vehicles returned to combat within days. The industrial machine that had buried Germany now threatened to bury communist forces in Asia. Soviet engineers who had captured German technical documents, including some of Hans's reports, studied American methods with the same desperate intensity Hans had once applied. They learned the same lessons. The T-34 tank that had overwhelmed German forces on the Eastern Front had already embodied many Sherman principles. Crude by German standards, reliable in Russian conditions, built in numbers that made individual losses irrelevant. The Cold War became a contest of industrial philosophies. Both superpowers understood that future conflicts would be won not by the nation with the best weapons, but by the nation that could produce and maintain the most weapons under the worst conditions. Hans's insights, filtered through American and Soviet military doctrine, influenced tank design for decades. The American M1 Abrams, introduced in 1980, incorporated modular component designs that allowed major assemblies to be replaced in the field. The philosophy of treating maintenance as a design priority rather than an afterthought had become standard doctrine. Modern military vehicles across NATO and beyond reflect principles Hans first articulated in his 1944 reports. Quick connect systems, standardized fasteners, maintenance manuals written for soldiers rather than engineers. The assumption that equipment will break and must be rapidly restored. The numbers tell the story. During the 1991 Gulf War, American forces maintained operational readiness rates exceeding 90%, despite operating in desert conditions that destroyed equipment rapidly. Iraqi forces equipped with Soviet designs that had absorbed similar lessons still could not match American maintenance efficiency. The philosophy had evolved, but its core remained unchanged. In total, the design principles Hans identified have influenced military vehicle development in over 40 countries. The concept of designing for maintainability rather than pure performance has saved countless lives by ensuring that equipment works when soldiers need it most. And the industrial approach that produced 50,000 Sherman tanks during World War II established templates that continue to shape manufacturing philosophy today. Beyond military applications, the principles migrated into civilian industry. Japanese automotive manufacturers rebuilding after the war studied American production methods intensively. The Toyota production system, which revolutionized global manufacturing, incorporated ideas about standardization and maintenance accessibility that echoed what Hans had observed inside the Sherman. The tank that German engineers dismissed as crude became a template for industrial efficiency worldwide. But the real legacy was not about tanks or factories. The deeper lesson of Hans Meyer's discovery was never really about engineering at all. It was about how institutions respond to challenges that threaten their fundamental assumptions. German military culture believed in superiority. It believed that German engineering, German precision, German attention to detail would always triumph over inferior opponents. When evidence suggested otherwise, the institution rejected the evidence rather than questioning its beliefs. Hans experienced this rejection personally. His careful analysis was dismissed because it implied uncomfortable truths. His recommendations were ignored because implementing them would require admitting that the enemy had solved problems Germany had not even recognized. The institution chose pride over survival. This pattern repeats throughout history. Organizations that build their identity around superiority struggle to learn from opponents they consider inferior. The lessons are there visible to anyone willing to look. But looking requires humility that successful institutions rarely possess. The American military in Vietnam would learn similar lessons about underestimating determined opponents. Soviet forces in Afghanistan discovered that technological superiority could not compensate for fundamental strategic errors. Every generation produces examples of powerful institutions failing because they could not imagine learning from those they dismissed. Hans understood this pattern because he had lived it. In his later years working as a consultant, he often told younger engineers a story about the Sherman tank. They expected him to talk about armor or firepower. Instead, he talked about a maintenance manual. The Americans, he would say, wrote their manual assuming the reader was an intelligent partner who deserved clear explanations. We wrote ours assuming the reader was a subordinate who should simply follow orders without understanding. He would pause, letting the implication settle. That difference in assumption, he concluded, reflected everything about why they won and we lost. It was not about technology. It was about respect for human beings. The Sherman's secret, in the end, was a secret about institutional culture. The Americans built tanks for real soldiers in real conditions. The Germans built tanks for ideal soldiers in ideal conditions that never existed. One approach assumed human limitations. The other ignored them. And in a war fought by millions of imperfect human beings, the approach that accepted imperfection proved invincible. Today, business schools teach case studies about disruptive innovation and institutional resistance to change. They could use Hans Meyer's story as a perfect example. A single engineer saw the truth clearly. He documented it carefully. He presented it persuasively. And the institution rejected it anyway, preferring comfortable myths to uncomfortable realities. The companies that survive disruption are those that can learn from competitors they initially dismiss. The armies that win wars are those that can adapt to enemies they initially underestimate. The lesson applies far beyond military history. There is one final detail about Hans Meyer that most histories have overlooked. In 1962, Hans received a letter from an unexpected source. A German historian was researching Wehrmacht technical assessment procedures and had discovered references to Hans's 1944 Sherman analysis. The historian wanted to interview Hans about his wartime work. Hans agreed. During the conversation, the historian mentioned that he had located Hans's original reports in captured German archives now held by American institutions. Most had been translated and incorporated into post-war technical assessments. But one document had been filed separately, apparently overlooked during the initial archival processing. It was Hans's personal notebook, confiscated when he was first questioned by military intelligence in early 1945. Hans had forgotten it existed. The historian sent him a photocopy. Hans opened the package expecting dry technical notes. Instead, he found something that brought tears to his eyes. Between pages of measurements and diagrams, Hans had written a letter to his wife. He had never sent it, never expected it to survive. The letter was dated March 1945, written during the terrifying days when Hans was fleeing military intelligence investigators. In it, he described his fears for the future, his hopes that somehow his family would survive, and his conviction that understanding the truth was more important than believing comfortable lies. "I have learned something important," Hans had written. "I have learned that the enemy we despised built machines for real human beings, not for propaganda or pride. They assumed that soldiers would be tired, mechanics would be undertrained, conditions would be terrible. And because they assumed the worst, they built something that worked in the worst conditions. We assumed we were superior. We built for a world where German excellence would always triumph. And we were wrong." He had continued with words that seemed to predict the decades ahead. "If I survive this war," Hans wrote, "I want to remember this lesson. I want to remember that the best engineering is not the most precise or the most elegant. The best engineering is what works when everything goes wrong. The best engineering respects human limitations instead of demanding human perfection." Hans kept that letter framed on his office wall until his death in 1987. His children donated his papers to a small museum in Ohio that specializes in automotive history. The museum curator had no idea what the documents represented. They remain there today, uncategorized and largely unexamined, waiting for someone to recognize their significance. From a civilian engineer with no combat experience to a man whose insights influenced military manufacturing for generations. Hans Meyer's journey represents something larger than one person's story. He proved that truth can be found anywhere, that the most important discoveries often come from those willing to look where others refuse to see. The Sherman tank was never the best tank of World War II. Its armor was adequate. Its gun was sufficient. Its performance was acceptable. But it was built by the thousands maintained by ordinary soldiers and replaced faster than enemies could destroy it. In total, American factories produced over 49,000 Sherman tanks during the war. That number alone tells the story of industrial philosophy triumphing over engineering pride. Germany built approximately 6,000 Panthers, each one a masterpiece that required 3 times the production effort of a Sherman. The mathematics were simple. By the time Germany finished building one perfect tank, America had built 3 ugly ones that worked. Hans Meyer understood this arithmetic before anyone else in Germany was willing to admit it. His reward was suspicion, investigation, and exile. His vindication came decades later in principles that now seem obvious, but were revolutionary when he first articulated them. Design for real conditions. Respect human limitations. Build systems, not monuments. The Sherman was never invincible. It was something far more dangerous. It was repeatable. And in a world where wars are won by production lines as much as battle lines, repeatability proved to be the ultimate weapon. If you have ever wondered why some organizations fail despite obvious advantages, remember Hans Meyer standing in front of officers who refused to hear truth that threatened their beliefs. If you have ever seen a good idea rejected because it came from the wrong person or challenged comfortable assumptions, remember the German institution that chose pride over survival. And if you have ever doubted that one person can see what powerful systems refuse to acknowledge, remember an engineer who cut open an enemy tank and found not secret armor, but a philosophy of respect for human beings. That philosophy changed manufacturing. It changed warfare. It changed how we think about building things that must work when everything goes wrong. The Sherman's secret was never hidden in its steel. It was hidden in the assumption that the people who would use it deserved equipment designed for their real limitations rather than imagined perfections. Hans Meyer spent his career teaching that lesson to anyone willing to listen. Most institutions never learned it until they had already lost. Some never learned it at all. The next time you use a product with clear instructions, standardized parts, and easy maintenance, remember where that philosophy came from. It came from factories in Detroit and Ohio. It came from engineers who designed for the factory floor rather than the drafting table. And it came from a German engineer who was honest enough to admit that his enemy had built something better. Not better in specifications, better in understanding what machines are actually for. The Sherman was not invincible. It was something more important. It was built for human beings. And that made all the difference.